So we're going to see what are rectangular vector. So let me zoom in. This is what we can expect for rectangular vector. Okay, this is the graph, and then we can see we have x, y, z. Okay, these are the coordinate points, and then it's located to those at this point. Okay, so this is one example of a rectangular vector. Okay, and then you can see we have a 3D. So we have z, x, and y there. So this is actually how we are able to. Okay, so this is what we see when we cover the vector rectangular shape. So, and then you can see the angle, and then we got another one there. Okay, so this is just to give an idea of what a rectangular vector. Okay, let's see spherical vector. Okay, this is what you could expect, but before I move to that, let me just show you the formula that you get. Okay, for both. Okay, spherical, this is what you see on the spherical, and then this is what we going to calculate. Okay, instead of those x, y, z, so that's why we call it spherical. Okay, and this is one example of how we are able to find those values. Remember, this is what you see here, theta. This is where you can locate theta, and then this is where you can locate r. And then we got z, x, and y. X and y as you see here. Okay, just to give you an example. And then in order to solve for the to get those you could see the formula. Let's go back to the rectangular formulas. You can see this is how you can get that point, the magnitude. This is how you can get the magnitude at that point, x squared. So you will take x squared that you see here until there, plus y squared. This is where you see y squared plus z squared. That's what you're going to put there in order to get the magnitude. And this is a formula for the magnitude. And then if you want to get the tangent of theta, so this is how you do it, to be a y over x. And then in order to solve for theta, this is what you take as formula. So it will be this is to get for the phi. For example, if you have to get this is the formula that you can use, cos -1, and then you're going to use this formula so that you can solve for this phi. Now we move on to spherical. That is the formula you can use. Okay, it's also, you can also represent it in this form. And what you should know, what is r? This is where we find r. Okay, and this is how we got it. So from this, we just took this triangle, and then we try to solve for those angles. So this is what you see. We got this one, that one, and from there we could get we're just going to move. Okay, you move this on that side, so it will give you this equality, and then you can just replace black where you see r, and then these are the formula that we're going to use, and the one for z is actually here. Okay, let's see some more shape that you now cylindrical. This is an example of cylindrical. You see we have r, theta, and z. So meaning that this is how you can calculate the amplitude from the magnitude, and then theta equal to theta, and then the phi equal to negative cos, and then you got this fraction inside, similar to what we did early for the spherical. This is what we'll be using, and pay attention to this formula because we're going to need them later on. And then we go for another example for spherical. This is what you see here. So we're going to calculate based on these 3 units, And then in order to solve for sine, we took that triangle inside, so then we can solve for sine. This is what you see here. And then you have r, you solve for r here, so you're going to move this on that side, so then you're going to end up with this equation. And then the angle equal to the angle, and then this is the equation for z. Okay, and then remember that we started here, if I must take you back, and then from there we move, and then I just explained this part here. Okay, so it was just to give you an idea of how you can go about solving this question, and then what are the formulas that you will be going to need later on. Okay, all right, let's just continue.